Okay, this is part 2 of the video for explaining the final exam review for Math 110. Just did 1 through 4, so we'll pick up at number 5, which says to evaluate f of x equals 2x squared minus 3x plus 1 at f of, well, that should actually be at x equal 3. That's actually not very good notation. You evaluate something at a value of x. X equals negative 3. In other words, we're finding f of negative 3. So f of negative 3 is equal to what you get when you plug in negative 3 for x. So to do that, you want to carefully put parentheses around it, especially when it's squared, and substitute it in. Even there, parentheses are good just because it's negative. And then you've got the plus 1. So everywhere there's an x, you plug in a negative 3 in parentheses. All right, then you've got to be careful about order of operations. Square first. Negative 3 squared is a positive 9. Then times 2 is 18. Over here we've got to subtract negative 9, which is going to be the same thing as adding 9. 2 minuses make a plus, so that's plus 9, and then plus 1. Be very careful about signs, and then just add left to right, or actually here, since everything's added, you can add in any order you want. 1 plus 9 is 10, plus 18 is 28. There you go. All right, number 6, determine the open intervals in which the following graph is increasing, decreasing, and constant. Okay, so here you want to look at the graph from left to right, and you always read x. Okay, x is like a timeline. So you look at this from left to right, and it's increasing, going upward from forever ago, right, from negative infinity, because it keeps going to the left, all the way up to this point right here, which has x coordinate, looks like that's a negative 2. So from negative infinity to negative 2, it's increasing. And they said to write them as open intervals, so that means not including the endpoints. So no matter what the points look like, you don't include the endpoints when it says open intervals. So that's where it's increasing. Let me write that down. And then we have a place where it's constant, just straight across, and that's from x equal negative 2 to x equal 3. So negative 2 to 3. It's constant. Again, open interval, negative 2 to 3, constant. And then, finally, the third piece of this graph, as you can see, is decreasing from left to right. And that's from x equal 3 to forever, to infinity. So 3 to infinity is where it is decreasing. All right, number 7. Evaluate the piecewise function at the desired values. All right, so here what you want to do is look at this being a value of x, and this telling you what interval of values of x you use that piece. So for example, you use the piece negative 2x plus 1 if x is less than or equal to negative 1. You use the piece 3x minus 4 if x is greater than negative 1. All right, so for negative 1 in particular, that's where we use the equals negative 1. So we're going to use the first piece, and we're going to plug negative 1 in for x there. So we're going to get negative 2 times negative 1 plus 1. All right, this is number 7. We're plugging in negative 2 times negative 1 plus 1. Using, again, that first piece, where is it? There it is, for x equal negative 1. So calculate that. Negative 2 times negative 1 is positive 2, plus 1 is 3. That's for f of negative 1. And then they want us to find f of 2. All right, so let me write down f of 2, f of 2. So now that's our value of x. So we look at the piecewise defined function, and we say, all right, which piece do we use for x equal 2? Well, 2 is greater than negative 1. So we use the piece 3x minus 4. So 3x minus 4 with 2 plugged in for x is 6 minus 4, or 2. All right. Number 8, graph that piecewise defined function. Okay, so now I need to write it down. I probably should have written it down before. We've got f of x equals 2x plus 1 if x is less than or equal to negative 1, and 3x minus 4 if x is greater than 1. All right, so we've got a situation where it is broken into pieces at x equal negative 1, right there. Okay, here's your x-axis, here's your y-axis. So what we want to do is look at what's going on for each piece. One thing that's really good is if you notice that these are both linear functions. 2x plus 1, mx plus b, and 3x minus 4, also mx plus b. This one has a slope of 2 and a y-intercept of 1. This one has a slope of 3 and a y-intercept of negative 4. But we don't want the whole line. We just want part of it. So let's see, if we go for x less than or equal to negative 1, plug in negative 1 for x. In fact, we did that up here, and we got 3. And then another point to the left of negative 1, like negative 2. Plugging in negative 2 for x here gives you negative 4 plus 1, which is negative 3. Right? 2 times negative 2 plus 1 is negative 4 plus 1, which is negative 3. All right, so we've got these 2 points. Negative 1, 3 is the end point where this thing starts, where that part of that line starts. So negative 1, 3 is right, oops, can't draw through the phone. All right, there's negative 1, 3, that's like the end point. And then the point negative 2, negative 3, I have a problem here. What's this function? Just notice those points are way too far apart. All right, it's because I missed a negative. Yeah, I missed a negative. Don't do that. There's a negative 2, so that is a positive 4. So that is not negative 3 at all. That's 5. All right, now the reason I caught that is because if you plot that point that I was going to do, it would have had a really steep slope. But the slope of this line is negative 2. So it shouldn't have gone down that far. In fact, it should have gone up from there. So yeah, all right, so we got a point of negative 2, 5. Sorry about that. Gotta be so careful with math. All right, negative 2, 5. So that is, let's see, negative 2, 5 right there. All right, so what's going on is this piece of the line that we want is from there up. All right, actually it's decreasing if you look at it from left to right, but that's the end point where that piece ends, okay? Because then we want to use the other piece for x greater than 1. All right, now it gets infinitely close to 1 though. So what we want to do is, or negative 1. So what we want to do is still plug in negative 1 and just realize that that's going to be an unincluded endpoint, an open endpoint, meaning it gets infinitely close to that, but doesn't actually get there. So plugging in negative 1 to that piece, you've got 3 times negative 1 minus 4. See if I can get this correct here. That's negative 3 minus 4, which is negative 7. All right, so negative 1, negative 7 is an open endpoint. So if you go over to the graph, negative 1, down 1, 2, 3, 4, 5, 6, 7 is right there, and we want to open dot. Okay, then we want to find another point to the right of that for the rest of that piece. So let's just use 0. 0 is an easy number to plug in. Plugging in 0 for x here just gives you -4, the y-intercept. So that's right there. And this line then goes from that open dot all the way up to infinity. And there's your graph.